Hello everyone and welcome back to the MicroWeave-TEX project podcast series. This episode is part of the MicroWeave-TEX project, whose main aim is to develop sustainable solutions in the textile industry to mitigate the release of synthetic microfibers throughout the entire value chain. That is, from the very beginning in the design phase of textile products right through to the end when they reach the end of their useful life. So what does this project involve? Basically, we focus on training both teachers, educators and students in various ways, such as through this podcast series or later on with educational and training materials. Today we have a guest with us, Matilde Azubel. Thank you very much, Matilda, for accepting our invitation to collaborate with the MicroWeave-TEX project. If you like, who is Matilde? Tell us a bit about yourself and what connection you have with microplastics.
I'm Matilda, I'm Argentinian, I'm in my second year at the Polytechnic University of Valencia studying biotechnology, and I'm part of a spontaneous generation group called Proluo. The aim of Proluo is to work on developing mechanical filters that manage to remove microplastics found in the oceans and in bodies of water. And for this, different prototypes are designed which are attached to the undersides of boats. So when these boats follow their usual routes, it's thanks to the movement they generate that the water passes through our filters and the microplastics are trapped. And in this way, they're removed from the oceans.
I mean, in the end, you combine your university studies with research outside a class, together with other classmates, I imagine, because Proluo is a spontaneously formed team. Could you tell us what these kinds of spontaneously formed groups are like?
Yes, well, Spontaneous Generation is a brilliant university-wide initiative where students from any discipline come together to work on different projects. There are a wide variety of different projects, cars, motorbikes, or pretty much whatever you can imagine. And you do not necessarily need to be studying exactly what you're working on. I did not actually know how to make mechanical filters, obviously because I study biotechnology, but I'm deeply and genuinely interested in microplastics and the ongoing sustainability challenges, especially in the oceans. So I joined the group, and there we teach each other, we develop new ideas, we go to the lab, we take samples on the beach, we learn new things, we do 3D printing.
How many years has the team been operating, roughly?
The team's been running now for 5 or 6 years, if I recall correctly, since 2019.
And how many people is it made up of, roughly?
Right now, I think there are actually almost 25 of us in total.
Ah.
Yes, it started with 3 lads who were studying mechanical engineering, who cared about the environment, and one of them was starting up a recyclable bottle business. Together with their flatmates, they thought, what if we made a filter instead? And that's how the idea for Proluo itself came about, which means filter in Latin.
Yeah.
And that's how the idea came about. And from that moment until now, it has expanded with different departments and people.
Of course, because you combine your knowledge, each person brings what they know from their degree or their master's. So what do people usually study, the members of Proluo?
We study a wide variety of things. We have biotechnologists like myself, people from environmental sciences, mechanical engineering, industrial engineering.
Right. And roughly what stage are you at? Because you mentioned the implementation on ships for filtration. At what stage? Because I imagine that in the end, your main goal would be to move on from spontaneous generation to a startup or something much more professional, industrial, or even to sell it so it could be installed on any type of ship, ultimately aiming for the mitigation of microplastics in seas and oceans. So what stage are you still at? Are you still at the beginning in research? Do you already have developments, or is it ready to be launched on the market?
For now, we are in the early stages, where we are still testing different prototypes and the best way to filter the water. So for now, what we have are prototypes of how it would work, but we are still in the early stages because it's a very complex and highly interdisciplinary problem, and we wouldn't want to introduce something into such a large ecosystem without knowing for certain that it's going to work 100%. Because there's also the reality that if we get complacent and put the prototypes on the boat and they fall off, In the end, we're just adding more pollution and more things into the oceans that shouldn't be there. If the filters fail to function correctly, all sorts of things could go wrong. So it's really important to ensure absolutely that what we're doing...
Yes, not to do more harm than the good we want to do for the environment. And what impact are you hoping to achieve with your project? In the end, to take it to industry, I imagine. The ultimate goal of a Proluo would be...
The primary and overarching objective of Proluo is actually much more focused on achieving a significantly cleaner and healthier marine environment, and whether the project will eventually evolve into a commercial industry or a formal organisation, or perhaps remain as a research part of a university, is something that hasn't been fully decided just yet. I suppose this is also because we are simply not far enough along in the process yet to start seriously thinking about those specific details. So for now, the ultimate goal of Proluo is to help.
I imagine that during the development, and especially because in the end, well, you have the knowledge you've gained from your degrees, and after all, it's young people like yourselves who take part in the Generatio Espontánea groups. Have you already come across any technical challenges that you've managed to solve, or is there still something lingering in your mind that you haven't?
Yes, we come across technical challenges every day, in fact. There are lots of problems, especially with what would be the plankton, because in the end, it's the same size as the microplastics. So when it comes to separating the microplastics from the water, some plankton ends up being removed along with the microplastics. And to be able to distinguish between these two different elements, we're still working on developing a specific engineering design that allows them to be separated in a highly efficient manner without harming the plankton. Because, for example, at one point we tried to remove it using centrifugal force and mechanical forces, but the problem is that plankton is alive, so no, our calculations showed it wouldn't survive. And so that's another problem we keep coming across. It's not simply about removing the microplastics. It's much bigger than that, because it's not just about the size, as there are many things of that size in what is the vast ecosystem of the ocean. So that is, for example, one of the biggest problems, aside from materials and filter designs, because we design a filter and it doesn't work as we expected. It doesn't remove the amount of microplastics we wanted.
Your design is completely a mechanical filter then?
Yes.
I understand, physical, so it's by pore size, it doesn't let them through. I mean, it filters, basically.
Yes.
That's right.
Yes, because we thought that these large ocean-going vessels, where we want to install them, since they travel such incredibly long distances, if the filters needed a professional chemist or someone to be continuously monitoring and checking their operation, that would also significantly and substantially drive up the overall financial and economic expenditure of having and maintaining the filters. And we wanted a solution that was as straightforward, robust and durable as possible. Say you just position it directly underneath the ship, and when the voyages come to an end, you simply remove a container that holds the microplastics, insert a new one, and it continues to function effectively. So that's one of the benefits of it being mechanical.
Yes.
They require almost no maintenance at all, which really significantly reduces costs in the long run and greatly enhances their overall durability.
And if it's a filter that you remove and then replace with another, maybe not. But anyway, I'm asking just in case you're already looking towards that future. With the microplastics that you collect, are you thinking of giving them a second use, or perhaps collaborating with a company like, right, we'll reuse them and make disposable tableware or something else out of them? I don't know if that's something you've considered.
It wasn't really considered as such, but since we're individuals who are so deeply involved in the subject, we all know many different non-profit organisations that work on the recycling and creative reuse of plastics, giving them a second life and various other similar initiatives. But the idea isn't to just throw them away, because then we're not actually making any real difference at all.
So from what you're telling me, I see the technical feasibility is quite good, because in the end, let's say it seems like a simple product, doesn't it? The way you describe it, and the economic viability of the idea, do you see it as feasible so that it would be interesting to install on ships, or would it perhaps mean an extra cost that wouldn't be profitable? I imagine it would be, right?
Yes, well then
That'd be good.
At this particular moment in time, it certainly seems so to us, but In the end, we've learned that you always come across significant challenges and unforeseen difficulties as you go along. So, although at first it seems to us that the cost of installing and maintaining it is relatively low, for now the biggest costs we're encountering are those of the development process itself, because it not only requires a substantial group of highly dedicated and committed students with plenty of time to dedicate to it, but you also need a vast amount of materials to build the prototypes in order to test them properly. We're creating a continuous flow of water so we can put them in and test them thoroughly without having to go through the trouble of deploying them directly into the open ocean environment. So all those things do generate an economic cost, like the 3D printing.
And with that, in the end, you're receiving support from the university, I imagine, financial support from Generación Espontánea. But what would you need to, continue with your project? I imagine, above all, investment from external investors, perhaps? Or maybe collaborating with some organisation, I don't know. Since people will be listening to us, here's your chance and your moment to ask if you want.
That's a good point. Yes, at the moment we get our funding from the university through Generación Espontánea, and we also have external sponsors who give us money. However, the inevitable financial considerations and costs are always there. Basically, the more significant the funds, clearly, the better the overall quality of the materials and the more new things we can try out without having to carefully prioritise or make difficult compromises like that. So it's always incredibly important, and a great deal of investment is needed for things like high-end 3D printing. The actual three-dimensional printer itself, which obviously you have to purchase and acquire, the necessary materials for the prototypes, and then also when it comes to organisations that can help us, any form of assistance or support is always very much welcome, whether it's just sharing knowledge. But I think that at this particular moment in time, more than anything else, what would be most useful, apart from direct financial support and funding, would be people who are genuinely interested and want to get involved in any way they can, especially on the mechanical side of development. Not so much in the research area, because we already have plenty of people for that. But when it comes to the actual process of building physical things and having the necessary knowledge and skills, of course, we always help each other out. But there are times when we just don't know why the printer isn't working, and we have to sit down and try and figure out exactly what is going wrong.
Well, this is a good time to share Proluo's social media in case people want to get in touch with you, and if they have that training or knowledge, share it with you. You've already mentioned that you have enough people dedicated to research, so to speak, within the project. Is Proluo also linked to perhaps final degree projects or master's theses? Is there anyone who's linking their project to this and working on something related to microplastics and so on, or not at the moment?
Yes, they did have them. At the moment, this semester, I'm not sure, but there are several final degree projects and I think one master's thesis that we're involved in this, mainly in mechanical engineering, as they tend to benefit the most since it's a mechanical filter and they analyse the movement of water as it passes through it, or
yes.
Or those kinds of master's and degree courses.
Yes, of course. In the end, it's a good solution and something you're already making progress with, and you can get good results from it. Plus, you work in a group, so those are some quite interesting skills. And now, if you like, I was going to change the question a bit, and now a slightly more personal question, to see what you think about it. What do you think would be better, investing in preventing the release of microplastics, or, on the other hand, in those kinds of technologies and advances, like the Proluo filter, to try to capture those microplastics afterwards? Which way do you think it should go, eh? What do you think would be better?
I think it would be better to focus our efforts on prevention. Always, it would be better if there were a significantly smaller amount of microplastics, because even if the filters actually prove to be effective, in the end, these microplastics are consumed by fish, which we then eat ourselves, as well as being present in the water we drink. They release toxins into the water, which also ends up killing algae, plants and plankton. And it's a significant and pressing issue because we can't realistically expect that we'll manage to successfully extract and eliminate all those microplastics in time before any other living being is negatively impacted or harmed by them. So in the end, proactive prevention is always more important than simply getting rid of them.
So I imagine you think that there's a general lack of awareness among people about how many microplastics are produced, how many microplastics each of us generates every day, right? I imagine that at university you don't really get any specialised information or training on the subject of microplastics, I suppose.
Yes, it's mentioned in some classes. However, I also think that the lack of information comes from a more general level in society. Because in my case, perhaps because I study biotechnology, it is mentioned to us, since when we talk about biology, environments, ecosystems and solutions, it's necessary to talk about microplastics. But I wouldn't know how involved the topic is in
Otherwise,
Partly.
of course, a mechanical engineering degree, which you might need to manufacture the filter, perhaps that's where the mechanical engineer comes in. Now, obviously, the topic of sustainability is quite a hot topic and so on, but when it comes to the generation of microplastics produced during the manufacturing of any part, that's where, or simply through our clothing consumption habits, the washing processes we use at home, in the end we are, or when we wash the dishes, things like that, we can also generate those microplastics. So we do notice that deficiency, that lack of knowledge in this area.
Yes, in that sense, I completely agree. I think people don't fully realise the significant consequences their actions have, particularly when they are at home, on the environment. And nowadays, the amount of microplastics released by the textile industry is alarming. However, it's one of the most rapidly expanding industries due to society's constant consumption. People just keep going out and buying more and more clothes without taking proper care when washing them. The sponges used for washing up, the bits of microfiber found dissolved in detergents, cosmetic products, as well as hair products. Nowadays, it's very difficult to avoid it entirely. However, it's necessary to do so, even if it's just being informed about how we can start reducing all this consumption and the negative impact these fibres end up causing.
In the end, that's it really. We're talking about consumption, about personal habits. And now, to wrap things up a bit, I'll ask you a personal question. You, Matilda, in your day-to-day life, in your habits, what do you think you would need to change to reduce your generation of microplastics?
That is a very good question. And I think that personally, what I really should improve on is paying much more attention when I am buying things, especially when it comes to personal hygiene products related to my hair, in my specific case. I am carefully making sure whether they contain any microplastics and the significant impact they're having on the environment, because that's definitely one of the major areas in my daily life where I use the most different types of various products. And I'm sure there are many microplastics I'm not sufficiently informed about, and that's something I'd like to work on to improve in my daily life.
Right. In my personal case, it would be when I do the laundry, following the washing instructions that each garment comes with, because in the end, for the sake of convenience and speed, I usually just sort by colours mainly, putting whites and dark colours together, throwing everything in without really caring much about the material. And in the end, each material has its own washing instructions, its maximum temperatures to avoid degrading the fabric, and that degradation makes it more likely to release, well, a synthetic textile microfiber. So in my case, I would also go with the issue of washing. But I also agree with you about the issue of cleaning products, which people often don't realise can generate microplastics. Well, that's all, Matilde. Thank you so much for collaborating with us, for sharing your experience on Proluo. Honestly, to all the listeners, I recommend you take a look at your website and your Instagram, as you have a really lovely feed.
Thank you.
And in the end, the initiative you're pursuing is also very interesting, and it's something that really interests all the project partners. that you're young students who are involved and concerned about the environment and the future, so to speak, and that you're coming up with, well, solutions. Ultimately, you combine your free time and invest it in this research for the sustainability of the planet. So thank you very much for what you do and for having shared your experience here with us.
Thank you for coming.
Not at all.
Thank you very much.
That's all for today's podcast. Just to mention that these episodes of the MicroWeave-TEX project are funded by the Erasmus Plus programme, and with them we ultimately aim to provide training for people, young people and educators, as well as to promote textile sustainability throughout the entire production chain. Thank you very much for listening to today's podcast, and keep listening to the next episodes that we will be publishing. For any information you would like to know about this project, you can find us both on our social media and on our website. Thank you very much and see you next time.